Welcome back. Today we are going to talk about scatterplots and lines of fit. One thing I want to say right now is that sometimes people are still writing scatterplots as two words, right? Scatter big plots. We're going to be writing that as one word today, but feel like I should put that out there. Anyhow, so when working with two sets of data, like comparing, I don't know, height and shoe size or something like that, a scatter plot, you've probably seen and heard of, can be graphed by plotting these data as ordered pairs in a coordinate plane, right? So you would assign one of the variables, right, one of those sets of data to be the x, one to be the y, on plot. And the reason we like to do this is to describe trends in data, right, to make sense of the world around us. All right. So here, the scatter plot depicts the study habits and test scores for 5 students in an Algebra 1 class. So anytime you talk about linear modeling, you're always going to see some type of context like this where we teachers try to guilt trip you into studying more. I was like half joking, half serious. All right. So the scatter plot here, right? We've got our studying along the x, test scores along the y. So how long did the student who earned a 75% study? So what we do here is we go to about 75 here, right, between 80 and 70. I'm going to go across to the point, there you go, that models that, and then think what is its x coordinate, and its x coordinate is 5. So we would say 5 hours. That's how long that person studied. Now, we can also think the opposite direction. So what was the test score for the student who studied for 2 hours? So similarly, I go to where 2 hours is. Here's the dot that corresponds with 2 hours. And that person got the 60%. All right, so what tends to happen as the hours a student studies increases? So notice here, I'm not guaranteeing anything. I'm not saying that studying causes test scores to rise. We're just looking at what tends to happen. So we would say the test as the students who studies, or the length of time they study increases, right, going this direction, what's happening to our Y's, the test scores, while they're also going up, right? So we would say the test scores tend to increase. Alrighty. When considering trends in data, we often discuss what's called the correlation, which tells us the relationship between the sets of data. So there's 3 options here. The first one is a positive correlation. And what that means is as x increases, y also increases, kind of like a positive slope. Next follows what we call a negative correlation. And as x increases, y decreases. And then this last one is there's no obvious linear pattern. Everything seems kind of random. All right, so let's look at some examples here. All right, so this scatter plot here depicts the relationship between temperature and ice cream sales at a small ice cream shop. Oh, that's so funny that I have a question mark there when that should be a period. All right. How much money was made on the day the temperature was 75 degrees Fahrenheit? All right, so we're gonna look and see 75 degrees Fahrenheit. What's the sale here? $250. All right, so about $250 looks like. What was the temperature on the day they made $350? So we'll go 350, find that point, about 85 degrees Fahrenheit. All right, so does this data show a positive, negative, or no correlation? Well, as the temperature increases, what's happening to the ice cream sales? They're also going up. So that would be a positive correlation. So when analyzing scatterplots, we can model the trend using what's known as a line of fit. And so what this line of fit does is it helps us make predictions about the data. So here we're going to use a line with a positive slope, since this is a positive correlation, to model this relationship between temperature and ice cream. So the first thing we're going to do is draw a line that fits the data closely. Okay, so it doesn't have to go through every point, right? Because it wouldn't be a straight line, but we want it to model the data closely. So your line might be a little bit different than mine, okay? But I'm gonna try to draw my line so it goes about like this. Okay. So close doesn't fit. All the points, and you should have like typically the same amount, like above is below, just kind of close. So we're going to write an equation using 2 points that are actually on the line. So not 2 points that we have of data that we have, but 2 points that are actually on the line. So for example, I have this point, and this point seems to be on my line, and this point seems to be on my line. So we are going to use point slope form, right? Because we're going to points, we're going to find a slope. All right, so to find my slope here, I'm going to use the slope formula. I'm going to use the first 2 points. So we'll use this one here. Looks like 75, 250. This one here looks to be about 60, 100. All right, so we'll have 250 over 75, and then we'll have minus 100 over 60. Go back and watch my point slope video. If you're like, why is she putting those points in at the same time instead of doing the y minus y and x minus x? Because you'll hear my little spiel about that. Right, so it'll be 150 over 15 or 10. So now we just have to pick a point. I'll just pick 75, 250 to plug into my equation. So y minus 250 is equal to 10 times x minus 75. That's my equation. All right, now we get to do kind of some interpretation, which is fun. So we want to know what is going on with our slope. So remember, slope is the change in y's over, that little triangle means change, over the change in x. Okay, so if this is 10, we can really think of as 10 over 1. And we'll use that to talk about what's going on here. So first let's think about the temperature, that change in x being 1. So as temperature increases, by 1 degree, the ice cream sales tend to increase. Again, I'm not saying that they actually do, but just that they tend to increase by about $10 because it's our change in Y's. All right, now we can use our equation to estimate how much money will be made when the temperature is 78 degrees Fahrenheit. So that's our X value here. So I'll take my equation, Y equals, oh, just kidding, Y minus 250 is equal to 10 times, this is where I'm going to plug in 78, minus 75. So we'll have Y minus 250 is equal to 10 times 3, or 30. I'll add 250 over, and that'll be 280. So we would say about $280 is what we would predict, right, they would make in ice cream sales when the temperature is 78 degrees. All right, everyone, that's your introduction to scatterplots and lines of fits.